Hello, Algebra 2 students. This is lesson 54, and we're just doing the part A of it. We're not doing the part B part. Our objective for today is what are and how do you use polar coordinates? Now please don't be confused about polar coordinates just being coordinates that have been put in the freezer or that are from like where Santa Claus is from or something. Polar coordinates is a new kind of coordinates, and that's what we're going to talk about a little bit today. Now, notice if you look on this page, there is a black dot. Now, if I told you I was going to erase this black dot and that you would get some kind of prize if you could put it back in the exact same place, then you would need to figure out some way of measuring this so that way you could put it back in the same place. Now, what we've been using so far through our mathematics is something called rectangular coordinates. And so pretty much what would happen is someone using rectangular coordinates would say, hey, I'm going to measure this length here to the bottom of the screen. And then I'm going to measure this length here to the left side of the screen. I'm going to call one of them X and one of them Y. They would measure what those were. And then they would say, okay, that point is at the point X, comma, Y. Okay? And then if that point got erased, if they knew these two numbers, then they would be able to get back and draw that point again. Now, sometimes, maybe you don't want to use that method, or if what we're doing today, we're just going to use a different method. Think about if you did something different. What if you said, how far is that dot from the corner down here? And I'll call it distance R. And then, now obviously, there would be another point out here that would also have that same distance R, right? So I couldn't just use one number. I have to use the distance R and then maybe, I don't know, the measure of this angle, which we will call theta. So if I knew the measure of that angle and how far away from that corner it is, then I could give you the coordinates of that. So the coordinates of this would be R, comma, theta. And that is a polar coordinate. Now, when working with polar coordinates, the plane looks different. Over here on the left, so we have our Cartesian plane or rectangular coordinate plane. Notice we have an x-axis and a y-axis corresponding to the x number and the y number that you'd be given. And so you could plot a point. Oh, look, that point is at 4, 4. Or this point is at 2, 1. You could plot those points. You could do that. On a polar coordinate, this is what the plane looks like. Notice there's circles because everything on this circle would have a radius of 1. Everything on this circle would have a radius of 2. Everything on this circle would have a radius of 3. Everything on this circle would have a radius of 4. And then there's angle measures. So if you wanted something at 45 degrees, you'd come out over here. So if it was 3, 45, that point would be plotted right here. Okay, so let's try a couple of those. And these are actually a couple off of your worksheet if you haven't picked that up yet. It says plot the points with the given polar coordinates. So this first number is its distance from the center, and the second number is the angle off of the positive x-axis. So let's see about graphing this point here. So let's see here. My radius there is 3. So I know that wherever my point is plotted, it's going to be on this circle, because this circle has all the points with radius 3. So it's going to be somewhere on there. Then look for this angle, 30, 60, 90, 120, 150, 140. So that means my point is going to be plotted right here. Plotted right there. And that's it. I just plotted a point. Let's look at this one. The radius is 3. Again, just a coincidence. This time the angle is 0. So it's going to be right here. So it's going to be plotted right here. That's not too bad, is it? Good. And you just finish your full first page. Alright. Now these ones start getting a little bit more complicated, but still you can do it. It says convert each polar coordinate to a rectangular coordinate. So right now I have a polar coordinate. So this is my R and my theta, and I want to somehow convert that into an x, y. So let's see, what does that mean, my polar coordinate? Let's see if I can draw a picture of it here. That means I have a radius of 4, right, off of this angle here, and this angle right here is 60 degrees. 60 degrees. Well, couldn't I draw a right triangle with that information? And this side over here would be the opposite. This side down here would be the adjacent, and this side up here would be the hypotenuse. And I have just enough information then that I could find the opposite side and the adjacent side. So what I'll do is I'm going to say sine of 60 degrees is equal to the opposite. I'll just call that, in this case, this would be the y length, right? How high up this point is. Y over 4. And then down here, I also have the cosine of 60 degrees is equal to, well, this length from here, right? This would be like a coordinate plane there. From here to here would be the x distance. So it'd be x over 4, right? The adjacent over the hypotenuse. So all I have to do is solve those two. I'm multiplying both sides by 4. I'll end up with y is equal to 4 times sine of 60. Down here I end up with x is equal to 4 times cosine of 60. And really for coordinate planes, y is going to equal to r times sine of theta, and x is going to equal to r times cosine of theta. So if you want to write down those formulas, that'd be for the point r comma theta. You can convert any of them and find the x and the y's. So I'm just going to plug this in my calculator real quick and find the answers to that. So I'll have the point 2 comma 3.46. And that's my polar coordinate given the rectangular coordinate. Alright, one more. Let's go the other way. It says convert each pair of rectangular coordinates to polar coordinates. So what I'm trying to do is I have this x distance, which is 1, and I have this y distance, which is the square root of 3, and I'm trying to convert that. I need an r and a theta. So this angle right here is a theta, and this angle right here is the r. So then I know r is going, or r squared is going to equal to 1 squared plus square root of 3 squared, right? And if you wanted like a formula that you could use every time, r is going to equal to x squared plus y squared, the square root. Okay. For our case, is going to be r squared is going to equal to 1 plus 3. Coming down here, r squared is going to equal to 4, which means r is equal to 2. That's half my answer. And the other thing is I know tangent of theta, because the other thing I need is the angle, is going to equal to the square root of 3 over 1. So that means to find theta, I'm going to say the tangent inverse, or the arctangent, of the square root of 3 over 1, or just square root of 3. So I'll plug that in my calculator real quick. It's going to be 60 degrees. That's the other half of my answer. And yes, you could use this as a formula right here. Theta is equal to tangent inverse of y over x would give you that theta. Anyway, so then my final answer is going to be 2 comma 60 degrees. Alright, your homework is to finish up this worksheet. I have full confidence that you will do well. Feel free to text me if you have questions or to watch the video again. Good luck.